Hello everyone, I welcome you all again to the 6th lecture of Electromagnetic Induction. I am Sameer Lavankar. So, let us begin. So, a little bit about the course outline we were talking about in the last previous lecture. So, we started with introduction, that is the definition of electromagnetic induction, followed by the experiments of Faraday and Henry. There were 3 experiments, 1, 2 and 3. Followed by magnetic flux, that is what is phi b value, the formula of phi b. Then Faraday's law of induction, which states the EMF produced due to the magnetism involved. Next is Lenz's law and conservation of energy, as in why the conservation of energy, how is the energy converted from one form to another. Then motion electromotive force, that is the EMF induced or EMF produced is not only because of constant magnetic field, it can be due to constant movement of the conductor, either inside or other outside. And finally, inductance and AC generator is left. So, about inductance we have already talked about mutual inductance, and now we were in the last lecture we were talking about self inductance. In the last lecture we talked finally at the work done, we calculated this formula, which is W is equal to half L I square. So, let us move on to the further discussions of self inductance. This was the formula which we calculated in the last lecture. Just a little bit brief again. So, for self inductance, N phi b is equal to Li, EMF induced is equal to minus L di by dt, and finally the self inductance formula which we get using these all equations is L is equal to mu n square into capital A into small l. What is N here? N is number of turns per unit length. What is capital A here? Capital A is the area of the coil, small l is length of the coil. If the air is not the medium, if the medium is different, then the value or the formula of self inductance has to be multiplied with mu r, that is coefficient of relative permeability, and the new formula which we get is L is equal to mu r mu naught small n square into capital A into small l. So, let us move on to finally the work done is equal to half L I square, which we calculated yesterday by using a small amount of integration. So, let us move on to a little discussion more on the similar topics only. So, please look over this thing written here. So, this above expression reminds us of half mv square. So, what is kinetic energy? If you remember from the basic physics formulas, kinetic energy is nothing but half multiplied by mass multiplied by squared of the velocity. So, this expression reminds us of mv square by 2 for the mechanical kinetic energy of a particle of mass m, and shows that L is analogous to m. So, here what do we get the value of work? It is half into capital L into I square. So, what is the analogy here? That for in place of mass we can use the concept of self inductance, and in place of velocity we can use the concept of current. we can use the concept of current. So, that is written here only, and shows that L is analogous to m, that is L is electrical inertia. L is electrical inertia, and what is m? M is mechanical inertia. So, that is L is electrical inertia and opposes, what does it oppose? Oppose growth and decay of current in the circuit. What does mass oppose? Mass opposes velocity in any particular direction. But what does electrical inertia or what does self inductance oppose? It opposes the growth and decay of current, growth as in increase in current, decay as in decrease in current. Moving on. So, now a little more discussion is being talked about, and this is from this line. So, consider the general case of currents flowing simultaneously in two nearby coils. So, let us say there are two coils. Either this way or coaxially. Consider the general case of currents flowing simultaneously in two nearby coils. The flux linked, what does flux linked means? Flux linked can be flux linkage. So, flux linkage is nothing but N multiplied by phi. So, the flux linked with one coil will be the sum of two fluxes which exist independently. So, here the total flux will be addition of the both, that is superposition will be used for the total flux linkage to be calculated here. So, now the flux linked with one coil will be the sum of two fluxes which exist independently, and now equation 6.9, that is next line, would be modified into. So, here N1 Phi1. So, please understand what is the concept being talked here is, please understand it carefully. So, now we already know what is N phi. In the concept of mutual inductance, what we found out was that the flux linked is directly proportional to current, but a little more. Let us say the flux linked in solenoid S1 has to be proportionalized with something, then that proportionality will be with the current flowing in the other neighboring coil. So, if N1 Phi1 has to be involved for mutual inductance, we are talking about mutual inductance only, because in self inductance there is no use of any subscripts. So, now if the flux linked with current if the flux linked with solenoid S1 or coil S1 has to be proportionalized with something, then that proportionality will be with the current flowing in solenoid 2. If we need to convert this proportionality sign into equality sign, we will use the constant of proportionality as m. So, what will be this m? M is the mutual inductance of 1 with respect to 2. So, it will be M12. Simple clear concept is here. So, what does this last line says is that the flux linked with one coil will be the sum of two fluxes which exist independently. Therefore, the value of N1 Phi1 will be equal to the current produced in I2, and also if the current is produced in I1 and we need to calculate the flux linkage in other coil, then the value will be M11 I1. Now, so here the flux linkage N1 Phi1 will be equal to, what will be the flux linkages here? So, the flux linkages here will be one due to self and one due to mutual. So, what will be the mutual? Mutual will be nothing but M12 I2, and what will be self here? Self will be denoted by M11, because it is the inductance in coil S1 due to coil S1, and the current will be produced in I1 only. Therefore, it is just a simple addition of self and mutual, and hence it is written here, So, it is N1 Phi1, that is flux linkage is equal to M11 I1, this is M11 I1 and M12 I2, this is M12 I2. Moving on, where M11 represents inductance to the same coil. So, inductance to the same coil is nothing but self inductance. Therefore, using Faraday's law, what does Faraday's law states about? It is written here, the formulas are being updated. So, sorry. So, EMF produced is nothing but minus n d phi b by dt. From the last concepts known here, we calculated epsilon with a negative sign of self inductance or mutual inductance multiplied by change in current. So, just using the same concepts here, we get epsilon 1 is equal to minus M11 di by dt, which is minus M12 di2 by dt. If I need to explain it again, then it is nothing but d by dt of n phi N1 phi 1 is equal to d by dt of M11 I1 plus M12 I2. Putting a negative sign on both sides. So, this value on your left is nothing but epsilon 1 value, and this is equal to minus d by dt M11 I1 minus d by dt M12 I2. So, epsilon 1 is nothing but minus M11 di1 by dt minus M12 di2 by dt. So, this is nothing but this formula written here. Moving on. So, M11 here is the self inductance already told to you here and is written as L1. We already know that anything which is due to self is denoted by capital L and anything denoted by mutual, that is due to neighboring coil, is denoted by capital M. So, therefore, M11 is the self inductance and is written as L1. Therefore, epsilon 1 is nothing but minus L1. So, in place of M11 we wrote L1. So, epsilon 1 is equal to minus L1 di1 by dt minus M12 di2 by dt. So, this is the new formula which we got due to, so this is the new formula which we got, that is EMF produced due to a neighboring coil as well as the same coil. Then the flux linkage is due to both, it is due to the neighboring coil also, it is due to the same coil also. If we need to calculate the flux linkage due to same coil, then it is self inductance. If we need to calculate the value due to neighboring coil, then it is mutual inductance. So, this is the final formula which we got, that is epsilon 1 is equal to minus L1 di1 by dt minus M12 di2 by dt. So, let us now move to some of the problems related to inductance. So, please focus on the problem here. So, the question says that obtain the expression for the magnetic energy stored. So, magnetic energy is nothing but the work done here. So, what is the work done here? Work done is nothing but we calculated in the last lecture, that is half Li square, also written here for your quick reference. So, obtain the expression for the magnetic energy stored in a solenoid. What is a solenoid? It is a coil with many turns. So, that is a solenoid stored in a solenoid in terms of magnetic field B. Magnetic, you have to use the terms magnetic field B, then the area A and the length L. So, in terms of these three terms we need to calculate the expression for magnetic energy. First, let us calculate this value only. So, please look over the solution here. So, solution is UB is equal to half Li square is the formula used up here. The value of L, let me go back. So, the value of L we calculated is written here, that is mu r mu naught n square into capital A into small l. If the medium of relative permeability, as nothing is given in the question, so we assume that the air is the medium being used here and therefore, the value of mu r is 1. Therefore, the value of L is nothing but mu naught into small n square into capital A into small l. Now, current is nothing but B upon mu naught n. How does this value come? When we were deriving the value of when we were deriving the formula for mutual inductance, we got to know that B is nothing but mu naught n into I. So, calculating I value is nothing but B upon mu naught n. So, using this and this in this equation, we get this, and then a simple mathematical evaluation leads to the magnetic energy value of half mu naught into B square into capital A into small l. Please make sure that the final expression only involved these three terms, that is B, capital A into small l. Just a little teaching method is when you are trying to see the questions involved in which you have to obtain an expression, and if the terms are written there, then majority of the times only the terms involved will be used. Let us say a value of n in some other expression needs to be calculated, then the question would be framed in that way that the final value asked to you would be a function of n, b, a and l. So, please make sure that if the calculation is right, then the value you will get will be a function of B, capital A and small l, but there is higher chance that if you are not getting it a function of only these three terms, then you are making a mistake somewhere while calculating the answer. Just a little trick for your exams. So, let us move on to the second question here. So, the B part says this: how does this magnetic energy compare with the electrostatic energy stored in a capacitor? So, please look over here. So, the magnetic energy per unit volume. Magnetic energy per unit volume is we are denoting it by small ub. So, small ub is nothing but capital ub, which is magnetic energy we calculated just in the present A part problem over total volume. So, V is the volume that contains fluid, capital V is nothing but area multiplied by length, either it can be a conductor, either it can be a square shape, generally it will be a circle shape only, it will be cylinder only. So, here it will be capital A, that is the area of the circle here involved, and the length will be this. So, just iterating to you. So, this will be capital A here and this will be capital small l here, and the just let me change the color. So, the coil will be like this. Moving on. So, it is nothing but capital UB upon small a into capital A into small l. The value we got for UB was half 2 mu naught into B square into capital A into small l. Dividing this expression by capital A into small l leaves us with only B by 2 mu naught. B square by 2 mu naught, sorry, B square by 2 mu naught. So, small ub is nothing but B square by 2 mu naught. Now, from this expression what we got is that ub, that small ub value, first of all is a function of capital B and mu naught. Also, small ub is directly proportional to square of the B, is directly proportional to square of B, that is square of magnetic strength, square of field strength. So, energy is proportional to the square of field strength is the thing we got from this concept here, this problem here, and that is the end of inductance. So, just to conclude the lecture, let me revise some of the basic concepts again involved in mutual inductance and self inductance, because those are directly linked with AC generators, which I need to teach in the subsequent lectures. So, just a quick recap so that you remember everything again. So, the basic concept involved was in self inductance was nothing but the value of flux linkage is directly proportional to the current value. When we remove this proportionality sign, we get a proportionality concept, we got a constant of proportionality, that is self inductance here. Similarly, for mutual inductance it is nothing but n phi, let us say we are talking about one value that is directly proportional to current flowing in second, and similarly for the flux linkage linked with second solenoid is directly proportional to current involved in 1. If we remove the proportionality sign, then n1 phi 1 is directly equal to I2, and here the constant of proportionality is m 1 2, because it is the mutual inductance in 1 with respect to 2. Similarly, n2 phi 2 is equal to m in 2 with respect to 1. So, this is the basic concepts involved. Finally, also we found out the value of induction, that is EMF produced is equal to minus L di by dt. Hence, when we are trying to induce currents with varying current, if varying currents are being involved in a circuit, then EMF can also be produced. Finally, the value of L which we got was mu r mu naught n square into capital A into small l, and the value of mutual inductance which we got was mu r mu naught n1 into pi r1 square L. Just a little trick here to learn everything. Let us say you remember this thing. So, now for mutual inductance, for self inductance the value of n is same, because it is talking about the same thing only. So, here n1 is equal to n2, therefore, the mutual inductance is mu r mu naught n square capital A into small l. So, the value which we got is nothing but for not for m, which is for L only. This is the same formula which you got. So, remembering a single formula can help you revise both the concepts. So, this is the thing need to be talked about in inductance. In the next lecture, we will talk about AC generators. So, this is the course progress here. We started with introduction concepts, followed by experiments of Faraday and Henry, then magnetic flux, Faraday's law of induction, that is EMF produced, Lenz's law and conservation of energy is also done, motional electromotive force is also done. Inductance was divided into two parts, self and mutual inductance, and that is also completed now. In the next lecture, we will start with AC generators, the concepts of AC generators, the applications of AC generators, and so on. We will conclude with some problems, and that will be the end of electromagnetic induction. So, thank you for now.